Hi, and welcome to my channel, JaberTime, where I do math videos from algebra to calculus and differential equations, simplified with examples. Today I'm going to talk about designs and patterns and how could you use math to solve some problems and build expressions or formulas. The first page, here I have the title and a graph. Says there is more than one way to tile a floor. As you can see from design 1, I have a 1 by 1 black tile. Design number 2 is the same 1 by 1 black tile, and around it we have 1, 2, 3, 4, 5, 6, 7, 8 white tiles. Now if you notice, I counted them by looking at them one by one, and that's not the way we should do. One way to do it is, you could look at it, it's a 3 by 3. 3 by 3 is 9. Subtract 1 in the middle, which is black. Now you get 8 white tiles. So I'm going to show you in this video how we could count tiles, but in different points of view. Design number 3, we go around the white tiles and we make or build and use gray tiles. And that's how we're going to make designs. So if you have a room that is, let's say 25 by 25, the question is how many unit tiles of black, how many unit tiles of white, how many unit tiles of gray you're gonna have to need or use. So here's the picture one more time to stay focused. And now there is more than one way to tile a floor. Tiling a square room requesting a tile pattern of alternating black, white, and gray tiles, as shown in the picture on the right. Each tile is 1 square foot. Analyze the design of a tile pattern that we were looking at for a square floor. Describe as many patterns as you can see. Let's look at the first one. The colors alternate with each new square, black, white, and gray. That's so obvious and we mentioned it. Let's move on. The number of tiles along each edge increases by 2 in each design, 1, 3, 5. So along each side, let's look at the bottom side. Bottom side is 1, that's an edge as they mentioned. Bottom side is 3. Bottom side is 1, 2, 3, 4, 5. 1, 3, 5. So we're going to go 1, 3, 5. I believe the next one, without seeing it, it's going to be 7. So, third comment. The number of new tiles added to each design is a multiple of 8. See, we're going from very easy, very simple, to a little bit more into it, and even more now. There is always things in math that you could see and design and analyze. So let's look at the, I'm going to look at the 8, 16, 24 in the coming slides. But in the meantime, it says we're adding 8, then we're adding 16 and so on. These ones we mentioned earlier that it's 8. The white ones are 8. If you count the gray ones, that's what you're adding. It's 16. And of course, the story continues. Let's look at the last comment. The total number of squares is equal to the number of tiles along each or edge squared, the edge squared. Well, that makes sense. Number of tiles is 1 by 1. Number of tiles is 3 by 3, which is 9. Number of tiles is 5 by 5, which is 25. And the next one will be 7 by 7, which is 49. I want to take you back to this one right here that I mentioned. We are, the number of new tiles added to each design is a multiple of 8. 8, 16, 24. Here we go. How many tiles we have? 1. How many tiles we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 more new ones, 8 whites. The gray ones are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. So we're going from black 1, black 1, black 1. When you go from here to here, you're adding 8 white tiles. When you're going from here to here, you're adding 16 gray tiles. Now one more time, I added just one by one, but that's not the right way. The right way is looking for a design and make it. Imagine if this design is not design 3, it's design 75. Are you going to go around and count the gray ones just by counting if the gray ones were on the edge, of course, one by one? I don't think so. So this is what we're going to have in the coming slides. The number of new tiles added to each design is a multiple of 8, as you could see. 8, 16, and trust me, it's going to be 24 after. So here's one of the problems that says sketch the design for a square floor that is 9 feet by 9 feet. Well, you remember the first one and the second one, third one? I'll take you back. You see this right here? It looks like the center is black. That's one way to look at it. So for this one, I would say I need to look for the center. Since it's 9 by 9, then we're going to count 4 here and 4 here and 1 in the middle, 4 here and 4 here, 1 in the middle, and look for the center and make it black. Then go and fill it with white after, then gray, and so on. Here's the answer. I don't want to take your time, but that's how it works. Alright, so that's a 9 by 9 and the design is complete. You could pause the video by hitting the space bar. You could hit the space bar again, it will play. If you feel like I'm going too fast and you want to count them, just hit the space bar to stop the video. I'm trying as much as I can to make the video not too lengthy. I want to make it as short as possible, less than 10 minutes hopefully. If not, around 10 minutes. I think it's going to be fine for a video. Let's move on. Determine the number of new tiles added to design 2 to go to make it design 3, to create design 3. I have the whole picture up here, but we're focused on design 3. Design 3 has these gray ones that we came up coming from design 2. So our focus is the gray ones. How are you going to count them? As I said earlier, we're not going to count 1, 2, 3, 4. We're not going to do that. Here's one way. Do you see the picture? I see 3 here and 3 here and 3 here and 3 here. I don't want to keep talking. I'll just display it for you and we'll go over it with the picture in mind. Add 3 tiles to each of the 4 sides of the white square. So we have a white square like this one here. Add 3 tiles here, gray. Add 3 here. Add 3 here. Add 3 here. That's what it says. That is 4 by 3, which is 12. Then add 1 tile to each corner. Then once you add the 3 here and 3 here, you're going to have a spot here empty. And 1 here, 1 here, 1 here. Add them up to make it a square. So the number of additional tiles added to design 2 is, with this kind of counting, I do have 4 3s and 4 corners. But 3 refers to design 3, so I'm gonna focus on the number 3, meaning it's 4 times n, because design 3, I'm gonna refer to it as n equals 3. 4 times n plus 4. That's 4 3s and 4 corners. Let's take another one. This case, it looks like they're counting all the top ones, all the bottom ones. I use green here to make it distinguished from the blue ones. So once you cover that and you cover that, we're not looking at corners, as you could see. We're looking at 3 spots here and 3 spots more here. Let's focus and pay attention to the graph. We're going to add 5 tiles to 2 of the sides, the top side and the bottom side, and add 3 tiles to the other 2 sides, the right and the left. The number of additional tiles added to design 2 will be, that's 3 plus 2, you expand, you make the 3 5, you expand it by 2, 1 to the right, 1 to the left, becomes 5. So I get 2 of these guys, the top and the bottom side, and 2 of the 3s circled in blue, left and right. Let's use n. If this is design 3, I am taking n, which is 3, adding 1 left, 1 right, make it a length of 2 more, double that, top and bottom, take 3 to the right, 3 to the left, which is n for us for now, and multiply by 2. So that's another way to do it. Here's another way. Oh, look at this. That's so clear. 3 here, 3 here, 3 here, 3 here. 1, 1, 1, 1. Oh, okay. Add 3 tiles. That's 4 times. And then add the 4 corner tiles. It looks like we covered that already, but it's another point of view. So the number of additional tiles added to design 2 is 3 and 3 and 3 and 3 and 1 and 1 and 1 and 1. That's 3, 3, 3, 3, 1, 1, 1, 1, which means using the letter n for n, letter n for 3, I have n plus n plus n plus n and 4 units. That's another expression. One more. Determine the number of new tiles added to design 2 to create design 3. If you notice right here, I have design 2 next to me, and you see the green color right here. I want to show you that part in design 3. So we're coming with the gray ones around the design 2, which is already highlighted in green or marked in green. So it looks like, yeah, you could count how many new tiles coming, which is gray ones, but not by counting 1, 2, 3, by looking at it this way. Take a look. You can see that we have 2 squares, the new one and the original one. The original square design 2, which is a 3 by 3, that's 9, and the new design, which is design 3, which is 5, 3 plus 2, 5 by 5, and 25. So how can I find the gray ones? Well, I could just like subtract. The number of additional tiles added to design 2 is 25. Take away the inside part, which is 9, and that should do it. But referring to the number 3 for design 3, this is a 3 plus 2, so that's gonna be called for me n plus 2, and this will be called n by n. So yeah, 5 is looked at n plus 2, and 3 will be looked at as n, and that should do it. That's kind of like a quick and a shortcut. I like shortcuts, and shortcuts which are, as you could see, they're actually with logic, but they're good to use and have instead of counting gray ones 1, 2, 3, 4, 5. You don't want to do that, especially if you have a work that relates to designs a lot, and counting. You have to look for counting ways or methods. The more skills that you have, the more math that you're gonna like, and you're gonna score higher and make more money. That's my advice. So, my last slide. In the coming video, we will go over these 4 expressions and verify that they are all equivalent. I don't wanna make the video too lengthy. I think it's good enough for this video. So in the coming videos, we'll discuss some expressions and show algebraically if this is true and this is true, and we believe in all of them, why they are equal, or how can I provide to other students that they should be equivalent. That's in the coming video. I want to thank you for watching, and I'll see you in the next one. Thank you and take care.